And so for the next one, we're going to try the same thing. Maybe we don't have to do long division on this one, but we can go ahead and divide stuff out. Well, let's first try doing direct substitution, because that's always my first plan of attack. Negative 3 squared plus negative 3 minus 6, all divided by negative 3 plus 3. Well, if you look at this, I'm going to get 0 over 0, which tells me there's a hole in the graph, which means that I've got to do some factoring, or long division. Now, in this case, I can see that I am okay with my factoring, that I can factor the top and get x plus 3, x minus 2. And then on the bottom, x plus 3. Well, if I cancel out my common factors to get an approximate function, my limit as x approaches negative 3 can be approximated by using this function of x minus 2. So by direct substitution now, I get negative 3 minus 2, which gives me a limit. My y value is negative 5. Before, we could do it without direct substitution, so we had to do something to make it work. So anytime you get 0 over 0, please just come up with a way to get rid of the common factor. That may be long division, that may be factoring. And then we get something that looks like this. And so I'm going to do direct substitution and get the square root of 0 plus 1 minus 1 all over 0. There's our first issue. We have 0 on the bottom, but you'll notice the top also gives me 0. Well, in this case, it's a little bit harder to factor. So what I have to do is, and I apologize that your math teachers have lied to you up to this point. They always tell you get the square roots off the bottom. Well, in this case, I'm going to multiply by the conjugate of the top to put the square root actually on the bottom. And this is another form of rationalizing. This time we're rationalizing the numerator. And so I'm going to leave the function inside of the loan, but I'm going to change the sign outside. And that's all over the same thing. Now this is a really ugly looking 1 top and bottom, but I'm going to multiply by it. Well, on the bottom, what is not so bad is that I can say, well, the bottom is just x times this really ugly looking function. And for me and for you guys, please don't multiply out the bottom. You don't need to. There's no reason. It's just going to cause you more pain and suffering than you need to. On top, we do have to multiply it out. So I'm going to FOIL these together. Square root of x times square root of x plus 1 gives me x plus 1. Then outside terms would be 1 times this thing, so plus the square root of x plus 1. Then I'm going to multiply my inside terms, which would be negative 1 times the square root of x, which is negative square root of x plus 1. And then last, I'm going to take negative 1 times positive 1, which will give me negative 1. So that's just the top. And you can see that we have some things that will cancel each other out. This guy will cancel out with that one, and the negative 1 and the positive 1 will cancel out. So I'm left with an x on top. Already, you might see the next simplification that we can do, that we have the same number top and bottom of the fraction, so we can get rid of those x values, which leaves me with a function that says the limit as x approaches 0 of 1 over the square root of x plus 1, which now, if I do direct substitution, will save me some time. Now, I know this seems like a lot of work, but it's much easier than setting up a table or graphing this thing and trying to figure out what's happening. And so when I do this, I end up with 1 on top and the square root of 1 plus 1, which will give me a 1/2. And so the y value of this function as we approach 0 is 1/2. That's really what we're looking for. Then we get to a function that looks like this. So we will try direct substitution, always our first plan of attack. So we get tangent of 0 over 0, which we learned earlier the tangent of 0 is 0. So we get 0 over 0, which gives us a problem. So now, if I do my limit, I'm going to break this up, do a little factoring or rearrange tangent. I know tangent is sine of x over cosine of x, and I'm multiplying by the 1 over x that was originally there. Well, with a little maneuvering, because remember we can multiply in any order that we want, then I could rewrite this function, sine of x times 1 over cosine of x times x, as the limit of x as x approaches 0 of sine of x over x times 1 over cosine of x. Now, I told you that earlier that sine of x over x as x approaches 0 is 1. And we talk about this a little bit more in class. On this one, we get 1 over 1, because cosine of 0 is 1, which means my limit of this function is really just 1. And that's really what we're trying to do. So you just try to make it easier for yourself and work your way through the problems. Our final example looks something like this, and it looks really close to our limit as x approaches 0 of sine of x over x, which would be 1. But the problem is there's a 4 in front of, there's this 4 right here. So we need to somehow deal with that 4. If we can get the x on the bottom to have a 4 with it, then sine of 4x over 4x would also equal 1. So what I need to do is I need to not change the function, but I'm going to change the looks of the function by multiplying by 1. Now the one I choose happens to be 4 over 4, which means that my limit now is the limit as x approaches 0 of 4 sine of 4x all over 4x. Well, we talked about this earlier, that we could say, well, what's the limit as x approaches 0 of 4 times the limit as x approaches 0 of sine of x over x. Well, since these guys are our properties, when we approach a constant from any value on a constant, we get that constant. And then this one follows our property from up above, from using the squeeze theorem, means that we get 1, and therefore we have something that looks like this. 4 times 1 equals 4. And so that is our limit. So thank you for joining us today on our my explanation of examples. We will talk more about this stuff in class. I hope you guys have a wonderful day. Thank you.